Hello everybody, welcome to Unit 8 of our workbook or textbook, and this is all about graphing quadratics. Here we go. So we just came out of unit of factoring quadratics, and now we're going to start applying all that factoring knowledge to graphing all these quadratics. Alright, so let's see. Here's some of the standards we'll be going over, and let's look at this. So here's the first thing we're going to see is f of x equals a times the quantity of bx minus h squared plus k. Alright, so this is your vertex form of a quadratic. Okay, so this is one of the forms we're going to be talking about. And we're going to be starting with this form. Alright, and then we're going to move on to standard form and then back to this form, and we'll keep playing around with the two forms. But for our purposes this year in Algebra 1, we're going to get rid of this b here. So we're just going to be looking at this right here, okay? And this is going to follow the same rules as everything else. If you've followed the order of this textbook, you would have also done a times the absolute value of x minus h squared, just joking, absolute value of x minus a times the absolute value of x minus h plus k. Alright, so these are going to follow the same rules over and over and over again. So the a, the h, the k, the b, they're all going to follow the same rules for any function you write. So let's see what we got. Alright, so we have this. This is the general shape of a quadratic. Another common name is a parabola. I will write that down, parabola. Alright, or also known as a parabola. No, just joking, parabola. Alright, it looks like a U shape, very similar to the absolute value. The absolute value was a V shape, but the quadratic is also a U shape, and we'll talk about all the features coming soon. Alright, so this is all in your textbook, 8.1. A quadratic function. Notice they have a different form here. Right, so we have the standard form, which is y equals ax squared plus bx plus c. Alright, so we have that form, and then the other form I just showed you, y equals a times the quantity of x minus h squared plus k. Alright, this first one is in the standard form. Alright, this first one here in red, circle that. That's in standard. And then we'll see very soon that this is in vertex form. Alright, and we've got a couple characteristics of the function here. So f of x equals x squared is the basic of all parabolas. This is the easiest of all the graphs we're going to draw, and this is called the parent function. Okay, so nothing's happening here, and there's no transformations going on, and we'll talk about the transformations that are going to be very soon. Alright, so this is called the parent function. Alright, so that's our basic U-shaped, starting here at the origin, which is also known the vertex. Okay, so the bottom of the parabola, or you'll soon see the top of the parabola, but this coordinate here, the bottom of the U or the top of the U soon, is also going to be the vertex. And this parabola has a certain feature that there is absolute symmetry along this line. So if I were to draw a horizontal line anywhere, the distance from this coordinate here to the line of symmetry is the same as the distance from here to that same coordinate there in the middle. Okay, so those two distances will be the same, hence making a line of symmetry here, or known as the axis of symmetry. Alright, and the axis of symmetry is a vertical line, and if we remember, horizontal lines also always take the form of y equals some number, and a vertical line always took the form of x equals some number. So if you notice, the x value here is 0, 1, 2, 3, and -1, -2. So if this axis of symmetry is going through x equals 0, okay? And we'll talk about different different axis of symmetries coming soon. Alright, but this is a little quick characteristics of quadratic functions. Alright, pause, read this over. Again, this is all in your textbook, lesson 8.1. Alright, so we're about 4 or 5 minutes in. Let's see how far we get. Alright, so what we're going to work on today is we're going to talk about the a value here, okay? So we have f of x equals ax squared, okay? So the basic function, the parent function, like we just said, is f of x equals x squared. And when that happens, to be the parent function, the number 1 is imaginary, right? The imaginary number 1 in front of the x there. But that's always going to be there, and that goes to this. So this blue line here is my parent function. This is what the parabola will look like. But then something happens. Okay, so what if I change this number here to something else or something different than a 1. Okay, so this number 1 can change to anything else. All right, so now I'm going to concentrate here on the green line. So what happens when f of x equals ax squared, but this time my a value is greater than 1? Right, so for example, what if I had f of x equals, I don't know, 5x squared, or 6x squared, or any number greater than 1, okay, or 3x squared, okay? Any number greater than 1. And what that happens is if you look at this green line here, right, if you want to kind of think about this as my little man here, and here's his arms and his thumb, and he's stretching way in the sky here, and there's his arms there. I'm sorry, I'm not the best artist, but there's his arm there, okay, there's his hair, blah, 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 and he's stretching way up, okay? So when that happens, so when a is greater than 1, we have something called a vertical stretch. Okay, so I'm going to say that again. When a is greater than 1, we have something called a vertical stretch. I'm going to highlight that for you here. Okay, so when a is greater than 1, it's a vertical stretch by a factor of whatever the a value is. Okay, and I'm going to erase the rest of this piece here. Okay, so I'm going to erase my little man there. Alright, so when a is greater than 1, we have a vertical stretch. Okay, so then the opposite would be, well, what happens when a is, I'm not going to say less than 1 yet. I'm going to say when a is a number between 0 and 1, so meaning any fraction here. So I'm going to do this one in red. So what happens when f of x equals, and we put a fraction in front of here, like 1/2 or 1/3 x squared. Okay, so this is no longer a vertical vertical stretch. Now this becomes a vertical shrink by a factor of 1/3. Okay, so first one, when a is greater than 1, we have a vertical stretch by a factor of 3. When a is between 0 and 1, so any fraction, any decimal between 0 and 1, will give any decimal, any fraction, 0.125 x squared. Right? Then my graph here is in red, if you notice, and this is actually called a vertical shrink. Okay, so the graph gets a little wider, where the green, when a is greater than 1, my graph gets a little more narrow than my parent function in blue. I always think about, the goal here is to reach infinity up here, to get to infinity, and if a is greater than 1, I'm going to get there faster than if a is 1, or if a is less than 1, or between 0 and 1, right? So I'm going to rise quickly and get there as fast as I can when my a value is bigger than 1. Alright, so there's two features of the a value, right? So a is greater than 1, so it's a vertical stretch. A is between 0 and 1, it's a vertical shrink. And then what happens when a is less than 1? Okay, so two things can apply here. Okay, so the fact that if a is negative, so if a is negative, okay, I kind of want you to look at this as two separate things. So if a is f of x equals negative, let's say 2x squared, okay, I would still consider the 2x squared as my graph having a vertical stretch. Okay, and then I would look at this negative sign differently or separately, and all that's going to do to my graph is, rather than making my u go up, it's going to make my u go down. And you can see here in this blue line here, that would be the blue line or the red line or the green line, right? These are all going facing down. This is what happens when your a value is -1 or negative. So if you want to think about this, I'm going to erase this here for a second, and I want to rewrite this function here as f of x equals -1 times 2x squared. Right? So this -1 is what makes it go upside down, or instead of saying upside down, I'm going to use some better terminology here, and I'm going to say this gives it a reflection in the x-axis. Right? So when the a value is negative, this gives it a reflection in the x-axis. When the a value is greater than 1, then I have a vertical stretch by a factor of 1. Right? And this could be a fraction as well. So if this was f of x equals -1 times no, 1/3 x squared, and these are just arbitrary numbers I'm making up. Again, this negative 1/3, this negative 1 is going to follow the same properties. It's going to give it a vertical reflection over the x-axis. The 1/3 is going to follow the same properties. That is going to be between 0 and 1, and we give it we call this a vertical shrink by a factor of 1/3. Alright, so there's a bunch of properties or a bunch of characteristics of the graph. This video is obviously going to be a little bit longer. We're at 10 minutes in, but let's take a look at some examples and see what's going on. Alright, and then I'm going to talk about some characteristics here back in the other page. I talked about when it's decreasing and when it's increasing, axis symmetry, and then we're going to bring back some terminology like domain and range that we've hopefully covered at this point in the curriculum, right? So it's the graph g of x equals 2x squared compared to the graph of f of x equals x squared. So I'm going to graph this one time for us, the parent function f of x equals x squared. All right, and I'm going to make myself a little xy table here, or an f of x table. I'm going to start with 0. So if I plug in 0 into my function, f of 0 equals 0 squared, and I'm just going to show you a few of these, how I get this, and 0 squared is 0. F of 1 is 1 squared, and 1 squared is 1. F of 2 is 2 squared, and 2 squared is 4. Right? And I'm going to put these in parentheses. Okay. Anytime you substitute in for a variable, I probably get in the habit of putting those parentheses. And I'm going to go to the negatives here. F of negative 1 is equal to negative 1 in parentheses squared, and negative 1 squared is also 1. F of negative 2, I'll put that in parentheses, and negative 2 squared is 4. Okay, be careful if you're putting this into the calculator. If you put negative 2 squared, you will get negative 4. If you put that in parentheses, then that's how you get the positive 4, which is why I said open up a set of parentheses anytime you substitute in for a value of x. Alright, so this is my parent function here, and I'm going to take a second and graph this. So 0, 0 is here, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And this is where the axis symmetry is really nice. And if you did 3, that's fine. And if you did have 3, here's 3, and you have 4, 5, 6, 7, 8, 9. I'm just going to put that 9 there. And then negative 3 also comes up to 9. And then my parabola looks something like this. I'm going to freehand this to as best as I can. There's my U shape, something like that. And voila. Alright, and there's my U shape. So this is this is the parent function, right? This is the most basic of all my quadratic functions here. F of x equals x squared. Alright, so now the other one here is g of x equals 2x squared. So g of x equals 2x squared. Again, I'm going to make myself a little table here. These first few are going to take a little longer, but as you get used to it, it'll be a little easier. Alright, so I'm going to plug in 0, so same rules apply. Here, so I'm going to have g of 0 equals 2 times 0 squared. Well, 0 squared, well, I'm going to do order of operations first, so I'm going to do the 0 squared first. Okay, so I'm just going to erase that. 0 squared is 0, and 0 times anything is 0. Then I'll do 1. Alright, so g of 1 is equal to 2 times 1 squared. Exponents first. 1 squared is 1. 1 times 2 is 2. And then while I'm at it, I'm going to do g of negative 1. And this will give me 2 times quantity of negative 1 squared. Again, I'm going to do negative 1 squared, which is negative 1 times negative 1, which is 1. And 1 times 2 is 2. So when x is negative 1, my y value is also 2. And that should happen because this is how I have symmetry. Alright, so as I move to the right one, I can get to a y value of 2. As I move to the left one, I get to a y value of 2. So I'm going to plot these 2 points. So 0, 0. And I got 1, 2, negative 1, 2. Okay, let's do a couple more. So I'm going to do g of 2 is 2 times 2 squared. 2 squared is 4. 4 times 2 is 8. So 2, 8. So here's 1, 2 on my x-axis, and then 1, 2, 3, 4, 5, blah, blah, and this is my 8 right here. And then if I do g of negative 2, I'm going to get the same thing. Negative 2 squared. Negative 2 squared is also negative 2 times negative 2, which is 4, and 4 times 2 again is 8. And again, this should give me this all should be the same distance from that axis of symmetry here, and we'll label that axis in 1 second, okay? So the axis of symmetry is right down the middle here for this problem. I'm going to put it in green. All right, you notice that these are all the same color there. And then I'm going to draw my U-shape to the best I can right there, freehanding, and my U-shape is going to look something like that and going up to infinity. All right, so now, what happened here? Well, I have an A value that's greater than 1. And my A value is greater than 1. So that means I have a vertical stretch. Okay? My vertical stretch here, right? Because my A value is greater than 1. And here's my parent function in black. Here's my new function g of x with a vertical stretch of 2, and it should be that is going to be a little more narrow than my parent function. Perfect. All right, so let me take some of these right here, group this, and we'll get rid of that momentarily. Voila, take that and put that over here. All right, and then so we have, now let's talk about some of these characteristics. Domain, range, increasing, decreasing. Now, depending on how you've learned domain and range in functions, okay, the domain for this one means, right, the domain is a set of all x values. Are you limited to what x values you can plug in? And the answer is no. You put in any x value you want. So your domain is, you can say all real numbers. Some notation will be negative infinity to positive infinity. In interval notation, you might see a notation that's negative infinity is less than x, less than positive infinity. All right, so these are all different types of notations that you can use. All right, so all real numbers, interval notations, negative infinity is less than infinity, close parentheses, okay? The parentheses means you cannot include infinity. And same thing here is with the inequality notation. And then let's talk about your range. All right, so your range are your y values. All right, so my domains are my x's here, my range are my y's. So what are my y values? So it's not all real numbers in this one, right? If you look at your graph, the lowest this coordinate goes, or the lowest the graph goes, is right here at the vertex. And what is that y value there at the vertex? The y value here at the vertex is 0. So your range is y is greater than or equal to 0. That's one notation. You can use another notation that bracket 0. That means you're allowed to equal 0 all the way to infinity. Parentheses, right? Doesn't all two different types of notation you could use here. So y is either greater than or equal to 0, or from 0 to infinity is your range. All right, so here's another one we got to talk about. Where is it increasing? Okay, so I'm going to go back a few slides here. And, right, so if you look at the slide here, it says decreasing, right? So you always read a book from left to right, and you're going to read the graph from left to right. So here you are coming from left to right. So your x, as you're moving left to right, your x values are increasing from negative infinity all the way to positive infinity, right? That's what's happening as you move left to right, right? Every time you choose a coordinate on this line, your x values are getting bigger and bigger and bigger and bigger and bigger, which is why we're going to read this left to right, okay? Because we want our x values to increase. So what's happening as your x values are increasing? Well, what's happening to my y values as my x values are increasing? Well, until I get to where x is 0 here, okay? Up until that point, right, until when I hit that bottom, as x increases, my y values are decreasing. Okay, so when is this decreasing? So if this continues, so way out here, x is coming from negative infinity, and it's going to stop at 0. So it's increasing, or I'm sorry, it's decreasing, right? So we got this. So it's decreasing from negative infinity all the way to 0. Or, in this case, when your y values are less than 0. Okay, so you can give me either notation, negative infinity less than 0, negative infinity comma 0, or 1y is less than 0, and you could use an equality notation as well, and we'll pick one. I do like the interval notation the best. All right, so I'm going to, not to confuse anybody, I'm going to start using this interval notation the most here, okay? And I'm going to stick to this one just to give you one notation to work with. All right, so we've been using inequality notation in the past, but here's interval notation. All right, so this is where it's not increasing, sorry, this is where it's decreasing, right? So we have it is decreasing from negative infinity all the way down to 0. I'm going to highlight the decreasing in yellow. All right, so it's decreasing from year to year. Now the question is, where is it increasing? Okay, and I'm going to highlight this in pink. We'll say, okay, it's increasing from here to here because it's starting to go up again. So where is it starting to increase? Well, it's starting to increase at the bottom of the graph at what x value? At x value of 0. And as you continue up this path, my x values are increasing and increasing and increasing. So where do they stop? Well, technically my x values will never stop. They're going to keep going to infinity. And as my x values get larger and larger and larger, so will my y values. So my graph is increasing on the interval from 0 to infinity. So decreasing from negative infinity all the way down to 0. Increasing from 0 all the way to infinity. Right? And this is, and then I'm always referencing with respect to x here, right? So always with respect to x. All right, and then the last one here is the axis of symmetry. Well, we said before the axis of symmetry is a vertical line. All right, and every vertical line has an equation of x equals something. So where is this vertical line? It's going through, where's the vertex of the parabola? The vertex of the parabola here is at 0, 0. All right, so the vertex here is 0, 0, and I'm more concerned about the x value here again. So whatever the vertex is, whatever the x value of the vertex is, that's where my axis of symmetry is going to be. X equals 0 based on that. All right, and get rid of these. I don't need these. All right, so here we graph the parent function f of x equals x squared. We graph the other function here, g of x equals 2x squared. We recognize that it's a vertical stretch. Okay, we talked about the characteristics, the domain. The domain is from negative infinity to positive infinity, or all real numbers. We talked about the range. Well, the range is the y values. The smallest y value is 0, and I'm including 0, right? So that the bracket here includes 0, okay? And the y value goes as high as infinity. And it's increasing. When is this graph increasing? Well, at the very bottom of the graph, it's not doing anything. It's not increasing or decreasing. It's just at the bottom, right? It's doing a little bit of both. So I'm starting at 0. And as my comma and as my x values increase, as my x values approach infinity, so will my graph. My graph will get, my y values will start to increase as my x values increase. And where am I decreasing? Well, if I consider my x values at negative infinity, as my x values travel closer and closer and closer to 0, my y values are decreasing, which is why here in yellow, this is where the graph is decreasing. All right, so there's a lot of information going on in this piece here. Okay, so the characteristics of domain, range, increasing, decreasing, axis of symmetry. The first 4 should have been familiar from functions. All right, hopefully you come back. If not, we'll definitely watch another video on functions and finding the characteristics of a graph. All right, if you need help in that, send me an email and I'll give you a link to a video. And then the axis of symmetry on this one is new. All right, let's take a look at one more example here. All right, and we have h of x equals negative 1/3 x squared compared to the graph of f of x equals x squared. All right, and let's see where we're at here. So we have our parent function. I'm not going to graph that parent function again. I'm just going to come back to this one and maybe I'll steal it from here. And there's my parent function. All right, there's the parent somewhere around there. Blah. Okay, and I did my best there. Okay, and then we have this other function here, h of x. So I'm going to do x and h of x in this one, and I'm going to start at 0. And what is h of 0? H of 0 is negative 1/3 times 0 times 0 squared. Okay, so 0 squared is 0. 0 times anything is 0. Beautiful. So we're both starting at the same exact vertex here. Okay, what happens when I go to 1? What happens when I go to 1 to the right? So if I move my x value 1 to the right, what happens when I move my x value 1 to the left? Well, my vertex is, right, here's my vertex, 0, 0. It's going to be the bottom of the graph, so my axis symmetry now is going to be x equals 0. Right, so I'll have a line of symmetry here. Okay, we're not doing anything yet with the vertex, so it's going to be at the origin for now. So what happens when I move 1 unit to the right and 1 unit to the left? I should get the same y value here. So negative 1/3 times 1, quantity of 1 squared. So 1 squared is 1. 1 times negative 1/3. So 1x is 1. Y is negative 1/3. 1x is negative 1. So I got negative 1/3 times negative 1 squared. Right? So negative 1 squared is 1. 1 times negative 1/3 is negative 1/3 again. All right? And let's give myself a couple more. How about h of, could do h of 2, could do h of 3. I'm going to do h of 3. And I should tell you why I'm picking 3. Negative 1/3 times 3 squared. And then I'm going to do h of negative 3, which becomes negative 1/3 times negative 3 squared. And both these answers should be the same. So 3 squared is 9, or negative 3 squared is 9. Okay, so you're both going to get 9 either way, whether you take 3 squared or negative 3 squared. You're going to get 9 either way, right? So then I have 9 in both those products, and when I square both of those, and then 9 times negative 1/3, well, it's going to be negative, and 9 times negative 1/3 is going to be negative 3. And I cheated a little bit here because I'd used the number 3 because I knew 9 would go into 3 even. I could have used 2, but when I squared 2, I would have got 4, and then when I got 4/3. So I chose 3 because I knew 3 squared is 9, and 9 would be divisible by 3 nice and easy. So when x is 3, y is negative 3. When x is negative 3, again, x is negative 3 as well. All right, can you think of another number that would go in there even nice and easy? So 3, 4, 5, 6, 7, 8, 9, like you can use any numbers you want, okay? But I'm going to stick to these, and this should give me more than enough to get a general shape to the curve, to the parabola, quadratic function here, or parabola. All right, so we got the 1/3 is a little hard to graph, but we'll get it in there. And then I'm going to use a 3 when x is 3. 1, 2, 3. 1, 2, 3. Negative 3. And when x is negative 3, 1, 2, 3. I got 1, 2. I get negative 3. And then I'll put the 1/3 in there. So when x is 1, I'm at negative 1/3. When x is negative 1, again, I'm at negative 1/3, somewhere around there. And my graph is going something like this. And like this. And again, for our purposes, that's more than enough for me to see that you have a general idea of what's going on here. Alright, so now, what's our a value? Our a value, so a is negative 1. I'm going to write this as negative 1 times 1/3, right? So we have the negative 1 here. So what kind of transformation is that? I'm going to type this one in. So this piece here is a reflection over x-axis. Alright, so we have a reflection over the x-axis. I'll make this a little smaller. Okay, so that's what the negative 1 does. And we'll highlight that like this. Okay, and then we have the 1/3, which falls in the category of a being between 0 and 1, and that's going to give us a vertical shrink. Right? So we have a vertical shrink, and we have a reflection over the x-axis. Alright, so those are the transformations of the graph. In the last one, our transformation was, we had that a was equal to 2 here. So the last one would have been just this a equals 2. This would have just been a vertical, oh yeah, we did that one here. A was greater than 1, so we just had a vertical stretch here. Alright, a is between 0 and 1 on this one, so it's a vertical shrink with the negative sign on the front, also giving it a reflection over the x-axis. Alright, domain. Am I restricted to any numbers I can plug into my x values? No. If I say plug in a number for x, you can literally plug in any number you like. Okay, so if that's the case, then my domain is from parentheses negative infinity to infinity open parentheses. This is another way of saying all real numbers. Okay, so depending on your teacher or where you're learning this, right? So negative infinity to positive infinity means all real numbers. Okay, your range. So how low is your range, or what's the smallest y value or the lowest y value you have? Well, this thing is going to go down forever into negative infinity. So my range is from negative infinity, 0, to where does it stop? Well, the tallest point of the graph is right there at the origin, and the y value there is 0. Are you including 0 or are you not including 0? And it is including 0, right? Because we got, here's one of our coordinates, 0, 0. So when I include the coordinate, I put the brackets there. So infinity is never included, so we always use parentheses. And the 0 is included, we use brackets. Alright, so if we're doing inequalities less than or greater greater than, this is your cases where you use parentheses. If you did greater than or equal to, less than or equal to, this is the case where you use brackets. If you think about inequality piece of this. Where is it increasing? Alright, so now we have a little difference here. So increasing, I'm going to use I use yellow for increasing. So this is where my graph is increasing, right? So if I read from left to right, my graph is increasing in this region here. So, or in that part of the graph. So I'm at negative infinity here, and my x values, right? This is going to go on forever, which is my x values there are at negative infinity, comma, and my x value, and it's going to stop increasing here again at the x value of 0. So it's going to stop increasing at 0, and I'm not including the top there because at the very top I'm not increasing or decreasing. And then where is it decreasing? So I'll highlight that piece here in green. It's decreasing right here. Right, this is where my graph starts to go down again. And so where is it decreasing? It's decreasing starting at 0. Just use a different color there. Decreasing starting at 0, right? Not including 0 because that's the top of my graph or the bottom of my graph, and there's no increasing or decreasing there. It's kind of neutral. And my x values are getting bigger as my y values are getting smaller and smaller and smaller, right? So as I travel down this parabola here, right, my x values are getting bigger, right? My x values are heading towards infinity, but my y values are going down or decreasing. So I'm decreasing from 0 to infinity. Alright, so we did a lot in this video. This is 8.1. We're about 32 minutes in, so a lot of information going on here. I'm going to stop here. Do some of these problems, practice problems that I assigned, and email me with any questions. Alright guys, good luck.